Okay, here are the solutions to the section 2.3 activity on differentiation formulas. So we're looking at the power rule, the quotient rule, and the product rule. So the first three questions here are really direct applications of the power rule. The exponent comes down in front and we go to, becomes the new coefficient, and we go to 1 less power. So the derivative of x to the 5/3 is 5/3 x to the 2/3, which is 5/3 minus 1. I rewrote the cube root of x as x to the 1/3, and then the derivative is 1/3 x to the negative 2/3. 2 pi is just a number, so this derivative here in number 3 is 2 pi x to the 2 pi minus 1. Can't really simplify that exponent in any way. Okay, in number 4, before applying the power rule, you could apply the quotient rule 3 times, but before applying the power rule, I just rewrote these all as negative exponents. So at this spot right here, I haven't done any calculus. I've just rewritten the exponent. 6 divided by theta is 6 theta to the negative 1. So we have 6 theta to the negative 1 minus 3 theta to the negative 2 plus 4 theta to the negative 4. And we're taking the derivative with respect to theta. So for the first one, the negative 1 comes down here when we take this derivative. Negative 1 times 6 is negative 6. And we go to 1 less power, which is the negative 2 power. So we get negative 6 theta to the negative 2 plus 6 theta to the negative 3 minus 16 theta to the negative 5. So all of these are just applications of the power rule. Okay, number 5 says find the equation of the tangent line to f of t is t squared minus 1 over t squared plus t minus 2 at t equals 2. I actually didn't even try to do some algebra. Maybe we could simplify this thing a little bit. But anyway, our job to find the equation of the tangent line is to find a point and a slope. The point that that tangent line is going to go through is right here. It's the point 2f of 2. So we need to evaluate the function at 2, and we do that, we get 3/4. So the point is 2 comma 3/4. The slope of the tangent line is going to come from the derivative evaluated at 2. So we take that derivative using the quotient rule. We have the denominator, t squared plus t minus 2, times the derivative of the numerator. The derivative of t squared minus 1 is 2t, minus the numerator, which is t squared minus 1, times the derivative of the denominator. And the derivative of t squared plus t minus 2 is 2t plus 1, all divided by the denominator squared. So right here is applying the quotient rule. Now you could try to do some algebra to simplify that, but really no reason to. You need to just evaluate it at 2. So when we do that, we put 2 in here everywhere we see a t. We get 4 times 4 minus 3 times 5 over 4 squared, which is negative 7/16. So here's our slope. And our point was 2 3/4, so our tangent line is y minus 3/4 equals negative 7/16 times x minus 2. Okay, number 6, similar. Find the equation of a tangent line. First, we need to think about how we're going to take this derivative. Here's a case where I did choose to do some algebra first. We could use the product rule right away, but we'd have to use the product rule with the quotient rule mixed in because of the 1 plus 2x divided by 3x. So instead, here I just did some algebra, some arithmetic. So right here I've done no calculus in this step. I've just rewritten the function as this function over here. 1 over x plus 5/3 minus 2/3 x is simplifying that function. And now I can take the derivative of each of these pieces separately. So this is just x to the negative 1. So its derivative is negative x to the negative 2 minus the derivative minus 2/3, because the derivative of 5/3 is 0, which is negative 1 over x squared minus 2/3. So the point, again, we're finding the equation of a line. So we need a point and a slope. So the point is 1 and the output of the function at 1. If we put 1 in there for x into our original function, the output is 2. So the point is 1, 2. And we need to find f prime of 1 then as the slope of our tangent line, and that is negative 5/3. And so our tangent line is y minus 2 equals negative 5/3 times x minus 1. Okay, last example. Find the equation of the tangent line to h prime. Well, okay, so the equation of the tangent line to the derivative Well, that would have to come from taking its derivative. So I would need the second derivative of h to get the slope of the tangent line to h prime. So I took the first derivative using the product rule right here. Make sure you can follow that along. And then I took the second derivative. These four terms come from using the product rule again. Now, the point that we're interested in, the point on our line is 1 comma h prime of 1. H prime of 1 is 15, so our point then is 1 comma 15. The slope is going to come from the second derivative evaluated at 1. And when we evaluate that second derivative at 1, we get 12 plus 18 plus 18 plus 6, which is 54. And so our tangent line is y minus 15 equals 54 times x minus 1. And again, it's because we want a tangent line to the derivative. If we wanted a tangent line to h of x, we would have stopped at h prime. But we want the tangent line to h prime, so we need to go one step further to h double prime of x to get the slope of that tangent line. Okay, last question comes from a definition. The normal line to a curve at a point P is the line through P that is perpendicular to the tangent line at P. Okay, so it goes through the same point. So if I want the normal line to the curves in number 5 through 7, okay, well, I need a point and a slope. Well, the point is the same, we were just told by that definition. And the only thing that's different is the slope. And now we have to remember, if two lines are perpendicular, what do we know about their slopes? If two lines are perpendicular, the slopes are negative reciprocals. Okay, so we need the negative reciprocal of negative 7/16, and that would just be 16/7. And so our normal line would be y minus 3/4 is equal to 16 over, whoops, sorry about that, 16 over 7 times x minus 2. Okay, again, coming down to the next example, the point doesn't change. It's 1, 2. The slope is the negative reciprocal, which is going to be positive then, because it's negative to start. Negative reciprocal is 3/5, and we get y minus 2 is equal to 3/5 times x minus 1. Last example. The point is the same as 1/15, and the slope is the negative reciprocal of 54, which is negative 1/54. And so the equation of the line is y minus 15 is negative 1 over 54 times x minus 1. All right, there are solutions to the activity from section 2.3. I'd be happy to take those. Any questions on that in our next Zoom meeting.